Hi, my name is Mike Fossum. I'm the commander of Expedition 29. Welcome to the International Space Station. You may wonder why the International Space Station doesn't tumble in its orbit around the Earth. Well, we have a system that maintains our attitude control system, if you will. There's really two ways to do this, to approach it. The first way would be to use rockets or small jets that would keep thrusting and pushing to nudge the space station into its correct attitude. Problem with using thrusters like that is it requires a lot of fuel that we have to continually ship up from the Earth. So instead, we use angular momentum and gyroscopes. Let me demonstrate a little bit. Before we get into this, we really have to talk about the definitions of the concepts. It's really the conservation of angular momentum that's really important here. I have this flashlight rotating. In physics, this angular momentum of an object rotating about some reference point right here in the middle, that's a measure of the extent to which the object will continue to rotate around that point unless it's acted on by an external torque. Now, torque has to do with the ability of a force to rotate an object and how far away from the center that force is applied. The angular momentum of a single rotating body is equal to the product of its rotational inertia, that's just physical properties of the mass distribution, the rotational inertia, and angular speed, how fast is it moving. The angular momentum and rotational inertia, that includes the mass, are constants in the system. Angular momentum of the system remains constant if no external force is acting on the system. This is the law of conservation of angular momentum. I can demonstrate this to you with me actually doing a little bit of a demonstration here. So I want you to watch this. I'm going to have to unclip the microphone or I'll tie myself up in knots. Again, what's going on as my body spins doing this and moving my arms in and out from being close to the body is when I bring the arms in closer to the body's rotational inertia is decreased. The angular momentum must be conserved. As the rotational inertia is decreased, the angular speed increases, and vice versa. This is called an inverse relationship. Now, no external force acts on the system, and thus the angular momentum about the axis must remain the same.